Welcome to this explainer. Let's just dive right into this with a pretty scary truth. Your AWS bill exploded before your app crashed. Back in the old days of on-premise data centers, if you wrote highly inefficient code, the CPU would just max out, your application would slow to a crawl, and eventually it would crash. But in the cloud, performance optimization is resource optimization. AWS is entirely elastic. It's designed to scale automatically to meet demand. So if your code is terribly inefficient, AWS doesn't automatically throttle it, it just throws more and more hardware at it to keep it running fast. And that is exactly why your application becomes incredibly expensive before it ever becomes slow. Let me show you how to actually optimize your AWS applications for both speed and cost so you don't accidentally bankrupt your company. Let's start with AWS Lambda and look at memory and scaling traps. The most critical execution behavior you absolutely must understand is how Lambda scaling actually works. When you configure a Lambda function, you really only allocate one primary resource, and that's memory. So a developer wants to save money, right? They set the memory to the absolute minimum, 128 megabytes. But in Lambda, CPU power and network bandwidth are strictly tied to the amount of memory you allocate. And this is where people mess up. Think about it like this. You have a compute-heavy task. At 128 megabytes, the function lacks CPU power and it takes 10 full seconds to execute. Because you pay for the exact execution duration, you just paid for 10 seconds of compute time. Now, if you bump that memory up to 1024 megabytes, it gets a massive CPU upgrade and finishes the exact same task in just 200 milliseconds. Even though the higher memory tier costs more per millisecond, the total execution duration is so much faster that your overall bill drops dramatically. It honestly feels like AWS math magic, but really it's just efficient compute. You must profile your application performance to determine the exact minimum memory and compute power required to find that perfect cost-to-speed ratio. Now imagine this. Your Lambda function needs to talk to a relational database. You write your code, and you initialize the AWS SDK and the database connection directly inside the main handler function. Every single time a user hits your API, Lambda creates a brand new TCP connection to the database, executes the query, and then tears the connection down. That network handshake alone takes 200 milliseconds. If your app gets 10 million requests a month, you are paying for 2 million seconds of pure networking overhead. To fix this, you absolutely must initialize your heavy dependencies and database connections globally, outside the handler function. When Lambda spins up an execution environment during the init phase, it establishes the database connection exactly once. Then, during the invoke phase, every subsequent request reuses that exact same connection. Your API latency drops, and your execution costs plummet. But what happens when thousands of users hit your API at once, and Lambda has to quickly spin up brand new execution environments? Well, you get hit with cold starts, which add massive latency delays to your application. To prevent these cold starts, developers enable Provisioned Concurrency, which keeps execution environments pre-warmed and ready to respond instantly. Now here's where this gets really dangerous. Provisioned Concurrency is not free. If you blindly provision 100 concurrent environments, but your app only actually needs 10, you are paying a heavy hourly rate for 90 idle servers doing absolutely nothing. You must actively monitor your concurrency metrics in Amazon CloudWatch and right-size your infrastructure. Your compute is now optimized, but your database is secretly draining your budget. Let's look at Amazon DynamoDB. DynamoDB charges you based on read capacity units, or RCUs, in write capacity units, or WCUs. Let's say a developer needs to find all recent orders placed by a specific user, so they write a scan operation. A scan reads every single item in the entire table before filtering out the results. It's literally like reading a 500-page book cover to cover just to find one person's name. If your table is 50 gigabytes, a single API request just consumed thousands of RCUs to find one single order. Because you have DynamoDB autoscaling turned on, AWS instantly scales up your provision capacity to handle this massive read load. Your application stays blazing fast, but your database bill just hit 5 figures. On the DVA-C02 exam and in real-world production, you must always avoid scans. You must use a query operation. A query uses the primary key to jump directly to the exact item, consuming just a fraction of a single RCU. Think about that for a second. You just turned a $1,000 database operation into a fraction of a penny, purely through better operational design. And if your API still demands extreme read throughput, you don't just endlessly increase your DynamoDB capacity. you implement application-level caching. By placing DynamoDB Accelerator, or DAX, in front of your database, you serve repeated read requests directly from memory in microseconds. Caching is absolutely the ultimate optimization strategy because it entirely removes the operational load from your primary database, drastically reducing your RCUs and API latency. Let's lock this down. Here are 3 rapid takeaways for you. Number 1. In AWS Lambda, CPU and network performance scale directly with memory. This means giving a function more memory often makes it execute faster and cost less overall. Moving to number 2. Always initialize SDK client and database connections globally, outside the Lambda handler, to reuse connections across invocations and eliminate networking overhead entirely. And finally, number 3, never use a DynamoDB scan operation on a large table. Always use a query or implement in-memory caching with DAX to protect your read capacity units from exploding. I want to leave you with one final warning. You cannot optimize what you cannot see. If you aren't actively monitoring your execution duration and auto-scaling events in CloudWatch, your first warning sign won't be a slow application. It will be a massive invoice from AWS. So take a look at your architecture today. What hidden elastic traps are secretly inflating your cloud bill right now?